Hey guys, I'm Topi Win, and today I'm going to be showing you how to work question 131 from Chapter 2 of Tro's Chemistry, a Molecular Approach. And this is going to be a challenge problem pertaining to natural abundance and how you're going to find the atomic mass of a certain isotope. And in this problem, it's going to be magnesium. So let's go ahead and read the question. It says, naturally occurring magnesium has an atomic mass of 24.312 and consists of 3 isotopes. The first major isotope is magnesium-24, which has a natural abundance of 78.99% and a relative atomic mass of 23.98504 atomic mass units. The next most abundant isotope is going to be magnesium-26, which is just going to give us the relative mass, which is 25.98259. And then it gives us the third most abundant isotope, which is going to be magnesium-25. And it's going to give us the natural abundance, but only in a ratio of 0.9083 to magnesium-26. And it wants us to find the relative mass of magnesium-25. So this may seem a little daunting at first. They're going to give you a lot of information and you may not know where to or how to use these numbers that they give you. So I always start off slow. I want to plan out what I want to find and how I'm going to find it. So the main goal here is that we're going to be trying to find the mass of magnesium-25. And how we're going to do that is we're going to use the equation we learned, or the formula we learned from earlier in this chapter. And that's going to be the atomic mass is going to equal the sum of the fraction of each isotope n times the mass of each isotope n. And it's just going to be every isotope that they've given us. So that's going to be magnesium-24, 25, and 26. So let's start off with what we know. In the problem, it gives us the natural abundance of magnesium-24, actually, the major isotope. And we're trying to find the natural abundance of magnesium-25 and magnesium-26. So an easy way to do this is going to be, let's check if that works here. Thank you. Is going to be if we subtract the natural abundance that they give us from magnesium-24, which is going to be 78.99%. 78.99% here. Sorry for my bad handwriting. 100% minus 78.99%, and that's going to give us 21.01% here. And keep in mind that this is going to be not their specific natural abundances. It's going to be the value that both magnesium-25 and magnesium-26 put together equals. So we can't use that for our formula yet. But we can manipulate it and try to fit in to the formula. And to start, let's change this 21.01% to a decimal. So it's going to be the fraction of magnesium-25 and magnesium-26 is going to be 0.2101. And that's going to be helpful for us later to find their specific values. And so at this point, we know the natural abundance of them put together, magnesium-25 and magnesium-26. We know that it adds up to 0.2101, but the only info we're actually given about their natural abundances is going to be their ratio to each other, which is going to be 0.9083. And so the way I approach this is I was going to use that value that they give us and use some algebra, or aka use an x value to find their specific natural abundances. So here's how I set it up. I'm going to let the x equal the fraction of magnesium-26, and I'm going to use the ratio of 0.9083x to equal the fraction of magnesium-25, because that's how they set it up proportionally in the problem. So if knowing that, we can assume that if we add them both together, they should equal the value that we got here, 0.2101, because that's their individual natural abundances put together. And now that we have that, we can actually just use our algebra skills to solve for x and find their specific values. So to approach this, I would just combine like terms and then divide by the coefficient. And once you do that, you should get a value of x that's going to be 0.1101. And now that we have that x value, we can find the specific value of the natural abundance of magnesium 26 and magnesium 25. And magnesium 26 is actually just going to be that x value we assign to it. No need to manipulate it there. Let me fix this. And then for magnesium 25, we're going to have to use that ratio they gave us, 0.9083 times x. So 0.9083 times 0.1101, which in the end you should get 0.1000. Very even number. And now that we have all these values, we have the natural abundances of each isotope, and we also have the atomic mass, or just the mass units of each isotope except for magnesium 25, which is what we want. We can actually fill in our formula now. Here's what I have down. 24.312 is going to be the just atomic mass of magnesium in general, and that's given to us in the equation. And here is the natural abundance and mass of magnesium 24 is also given to us in the problem. And this 0.1000 is going to be the natural abundance that we just solved for magnesium 25. This 0.1101 is going to be the x we solved for the natural abundance of magnesium 26, and then 25.98259 atomic mass units for magnesium 26, which is given to us in the problem above. And so now all we're looking for is this mass here, and you can, since it's just the single variable you're looking for, you can actually just solve for it, multiply these units together and these units together, subtract it, and then divide by 0.1000, and you should get a single value here of 25.06. And since these natural abundances only have 4 significant figures, so should our answer. And let's add some units. Atomic mass units. Thank you very much for watching. I hope I could help you all out, and I'll see you next time.